discuss classification of semiconductor in detail. To understand semiconductor and its classification, let us start with very basic thing, cloth. We know that these clothes are made from fibers, which are obtained from cotton. So cotton is that fundamental unit which is required to make cloth. Same is the semiconductor. Semiconductors are substances whose conductivity lie in between conductors and insulators. Semiconductors are basic elements of solid-state electronic device. We know that semiconductors are classified as intrinsic semiconductors and extrinsic semiconductors. Now we will study about intrinsic semiconductor. Intrinsic semiconductors are semiconductors in an extremely pure form. The commonly used intrinsic semiconductors are silicon and germanium. They are frequently used in manufacturing transistors and electronic products. An intrinsic semiconductor behaves like an insulator at absolute zero, that is at 0 Kelvin, and as the temperature increases, its conductivity also increases. Let us discuss how. Consider the crystalline structure and energy band diagram of silicon, which has 4 electrons in the valence shell. Each of these 4 valence electrons forms a covalent bond with its 4 neighboring atoms. Thus, an intrinsic semiconductor behaves like an insulator at absolute zero. Now, if the temperature is increased to 300 Kelvin, we see that covalent bonds break as they absorb thermal energy. When an electron breaks the covalent bond and jumps from the valence band to the conduction band, a vacancy is created in the valence band. This vacancy in the valence band is termed as hole. These electrons and holes are also called free charge carriers because they are free to move throughout the crystal. Since an electron is a negatively charged particle, so the hole created by an electron is assumed to be positively charged. Such simultaneous generation of electrons and holes due to an increase in temperature is known as thermal generation. Thus, we can say that intrinsic semiconductor is an undoped semiconductor, where conductivity is due to the movement of thermally generated free electrons and holes. We have studied that an intrinsic semiconductor has negligible conductivity at room temperature, so it is not of much use. To improve its conductivity, impurity can be of 2 types, donor impurity and acceptor impurity. Extrinsic semiconductor is basically a doped semiconductor on the basis of the type of impurity added. Extrinsic semiconductor is classified as N-type semiconductor and P-type semiconductor. Here we'll discuss about N-type semiconductor. But first, let us understand what donor impurity is. If the impurity consists of 5 valence electrons, then it is known as the pentavalent impurity or donor impurity. Some examples of donor impurity are arsenic, phosphorus, antimony, etc. Now, when a small amount of pentavalent or donor impurity is added to a pure or intrinsic semiconductor, the resulting semiconductor is called the N-type extrinsic semiconductor. Thus, an N-type extrinsic semiconductor is a doped semiconductor in which pentavalent or donor impurity is added to increase the conductivity of an intrinsic semiconductor. We have covered N-type semiconductor. Now we will discuss about P-type semiconductor. But first, let us understand what acceptor impurity is. If the impurity atoms consist of 3 valence electrons, then it is known as the trivalent impurity or acceptor impurity. Some examples of acceptor impurity are boron, aluminium, gallium, etc. Now, when a small amount of trivalent or acceptor immunity is added to a pure or intrinsic semiconductor, the resultant semiconductor is called a P-type extrinsic semiconductor. Thus, a P-type extrinsic semiconductor is a doped semiconductor in which trivalent or acceptor impurity is added to increase the conductivity of an intrinsic semiconductor. The related terms are